Ready?
Yep.
Hey Jonathan, I'm upset with you that you're not here. This is a lesson that you don't need to miss in person, but anyway, what are we gonna do? And, can you guys see this?
Yep.
Right now you can.
In honor of my birthday yesterday was the snow day, and these discs and washers, so sorry you missed. So we can save one for you. Does anyone know what kind? I think he likes Dunkin' Donuts. I forget. He had a specialty, but I forgot what it was. Okay, I'll save him one.
How long should it be before I cut
Let's
this
do
off?
10 to 12.
Okay.
All right, so we're gonna do from the homework number 11B, and that's where you had this. Did you draw it yet? Let me see. Did you put any effort into that one
Which one
yet?
is this?
I did not.
11B,
I didn't
11B.
do this one.
All right, well, you should at least set them up. Maybe if you can't do them, set them up by doing the drawing, writing down what's required. So can you quickly get this sketch? It starts abruptly at the origin and goes out ever increasing. Y equals square root of x. X equals 3, we'll cut that graph off right here, and x equals 0. So the area bounded by all that, now this is, was it x equals 0? Or was it y equals 0? Do you recall?
I think it was y equals 0.
Y equals
That
0.
would make more sense. Alright, y equals 0. So we're looking at this area right here, and we are spinning it around the y-axis. Alright, so I'm kind of stalling while you're catching up with your drawing. Alright, so when we spin that, this comes over here, and we have a weird donut. It's at the bottom side, I don't know how to say it, is rounded and flat, but the bottom's flat, but the sides are rounded. And then inside, though, it caves in, so I don't know how to draw that. But anyway, that's my attempt. So all I care about is the volume, and you're going to have to draw these sort of big so that you can see the pieces of your discs or washers. So I'm going to take one washer. We'll start out being a disc, but you can see that if I did all those pink discs from here to here, it would not include the caved in part or carved out part. So I'm gonna have to change my disc to a washer. And that's what we were studying the last day, Monday. So in order to figure out that, we learned that day that you take an integral and you're going to pile these washers up from here to here. So I'm gonna have to know the name of this point in reference to y. So Morgan, if this is the line y equals square root of x, and we're at x equals 3, 3 will be the x coordinate of that point, but what will be the y coordinate?
0.
This point is 3,
Oh.
0.
Just kidding. 3.
It's on this graph, so you're going to have to be able to find both the x and the y. So if you know the x, you just plug it in.
Oh, wow.
So
Okay.
what is it?
So you plug it so it's square root of 3?
Right, exactly. All right, so with that information, Gianni, what will the discs or the washers have to pile up from and to?
0 to square root of 3.
Right, so do you see that? The stack has to start at 0, sitting there on the x-axis, and pile up until we get to the top, which Morgan helped us identify the y value there at the top. So 0, the square root of 3. How can you get that any other way but with a picture and understanding what you're doing? So pi, and then we're going to do r squared, but remember it's the outer radius, I'll say, squared, minus the inner radius squared. And we kind of talked about that, why that was true before, so we'll just go ahead and do it. So with another color, let's look at the outer radius. So it starts here and it goes to here on the disc that I picked. So that radius, no matter where I put the disc, is going to be what, Brendan?
3.
It is. So we have a 3 squared, and then a minus, and now we need the inner disc. So the inner disc is going to go from here to here and stop, notice it hits on that purple line again, then that's very important. And that point is an x over, we'll call that point xy. That's very small, Jonathan, I don't think you can really see it, but it's an x and a y, where that point, that radius of the inner disk meets our graph, I'm calling that xy. So that means I went over x and up y to get to it. So, alright, so with that, what is the length, Aaron, of that inner radius, no matter where I put it? What could I call it?
You could call it x squared, right?
Just x, and
Oh,
then
just
the
x.
radius is x, and then we're gonna have to square it. Alright, now, back to you, Morgan. Is it the thickness of one of these washers? Is it a dy or dx?
Wait, can you do, okay, so it's y.
Alright, can
Yeah.
you see the thickness? Like if
Mhm.
that was a penny with a hole in it piling up on top of one another?
Yeah.
Can you see the thickness of each one is, and what you say?
Y.
dy. Alright, so Gianni, what are we gonna do about that problem? Because we have to do it in terms of x or y.
You have to turn the x and you have to in terms of y, so you
Right.
have to change the x.
So we have to mess with this, so that's not too bad. What is it?
Y to the fourth.
Alright, well that's after you've squared it, right?
Yeah.
So y equals x squared is a rearrangement of the original problem. So instead of x squared, x here, I'm gonna put y squared squared, and that's where he got the fourth from. Alright. Can you see where these things are coming from? Alright, Gianni, what was the problem when you were setting it up? Can you tell me?
I had a really hard time trying to figure out like what to put in where. As
Okay.
far as like the outer radius, the inner radius, it's easy when I
And
can
you're
see
watching
it,
me
but
do it.
Yeah.
I've been trying to find all those values
I
on
know.
my own.
These are particularly fall in that category. Are easy to watch someone else do it. Alright, so I'm going to drop you off there and allow you to finish that later. If you need an extra day to complete this assignment, I'll give it to you without penalty. Alright, what I want to do today is actually do 11C, set that up for you. I probably won't actually integrate it, I'm confident in your integration. That was not assigned, so this is a new thing that we're going to look at in 11C. And I need to make some forward progress, and after I finish 11C, I'll look at the time, and then we might just go and work on what you didn't do last night. I can help you set them up if you had other questions. Alright, so we're looking at 11C. My plan was, before I knew we were shortened, was to also do 11D, but I don't see. Let me go ahead and do D. I think it'd be more helpful. So let's do 11D. Alright, it's helpful. We already have the problem set up in front of us. Y is the square root of x. Y equals 0, y equals 3. This time, however, on part D, we are going to take this function and this area at 3 again, and we're going to revolve it around the line y equals 6. Woo! Around y equals 6, no, x equals 6, I'm sorry. Alright, we could do it either way, but this is what they asked us to do in part D. Again, this wasn't assigned because you hadn't seen this yet, so I'll assign a couple of these for tonight or later in the class. Alright, x equals 6, we need to find that. It's a vertical line at 6, 3, 4, 5, 6. Here is the axis of rotation, if you want its fancy name. So draw that and draw the axis of rotation. We're going to revolve it around there. Can someone describe in words what this thing is going to look like when I revolve it around this axis? Aaron, what do you see?
Would it just go to like 9 on
Right.
the other side?
Yeah, it will. So we're going to have a big hole, aren't we,
Yeah.
in the middle. So I'm going to take this. It's got to revolve around here, so I've got to go over here to this, and it'll show up about like that over there. So, sort of like a weird donut with a big hole. I don't know. some part in your car looks just like that, I'm sure. All right, so we're going to, obviously, because of this huge hole in the middle of it, we're going to have to use washers again. So this is the same technique. In fact, let me stop and I'll draw one and see if you can come up with the outer inner parts yourself, and then I'll jump in and see. So here's draw one typical washer. So there's the outer part. Okay, if we did all washers, we would have a solid upside down bowl. That is not what this is, so we have to cut out the inner part. So the inner part looks like that. Alright, so when you draw in your radii, here's two of them, let's connect them this way. You can draw a radius anywhere, but if we go this way, we're going to actually connect to our graph, so that will be helpful. So draw in the first radius, yes?
It's been 11 minutes.
Okay, go ahead and shut it down.